All right, hello Honors Pre-Calc. Today we're going to talk about section 8.3, which is going to be dealing with what are called geometric sequences. We've learned about arithmetic sequences already, so this is just a different kind. So looking at these examples here, I would just want you to look at the pattern, see if you can establish a pattern. So for A, what are we doing each time to get the next number? It looks like we are adding 7 each time. So that would mean that this is arithmetic. And the common difference would be a 7. For B, look at the list of numbers, the sequence, and see if you can figure out a pattern. This time we're not adding a number. It's not the same number that we would be adding each time. So you might switch your thinking and go, oh, it looks like we're multiplying by 2 each time. So that's the pattern. Now, when you are multiplying by the same number each time, that's geometric. And instead of having a common difference, now we're going to have what's called a common ratio. And the common ratio is the thing that you are multiplying by each time. So in this case, the common ratio is 2. We'll talk more about that on the next page. C, see if you can find the pattern. Are you adding something each time? Are you multiplying by the same thing each time? No, it does not look like we're adding the same amount each time, and it also does not look like we're multiplying by the same amount each time. So this is neither arithmetic or geometric. And this is what we will talk about more when we go back to section 8.1. So we started you off in section 8.2, now we're doing 8.3, then we're going to go back to 8.1, which is more generalized and trying to find more unusual patterns. We started you off with the easy arithmetic and geometric first. Okay, so what is geometric? Here is kind of your overview. Geometric is when you are multiplying by the same number each time to get the next term. The thing that you are multiplying by is called the common ratio, and we use an R to represent that. A ratio is when you divide two things. So if I want to find my common ratio, I could take my second term divided by my first term. Or I could do the third term divided by the second term. Or I could do the fourth term divided by the third term. Any term divided by the term before it. So if I look at this list of numbers right here, it's increasing pretty quickly. It looks like I'm multiplying by 3 each time. So that means that my common ratio is 3. But another way I could have figured it out would be to take 36 divided by 12, and I would get a 3. And that would work with like 108 divided by the term before it, 36, and I'm going to get a 3. Or 324 divided by the term before it, 108, I would get a 3. So it's a common ratio. Now that method might work for this problem right here. When you see fractions, it tends to get a little bit trickier to figure out what are you multiplying by. So if you take the idea of taking a term and dividing by the term before it, I could pretty quickly find my common ratio if I take this term, 1, and I divide it by the term before it, which was -3. My common ratio is -1/3. And that would work if I chose, for example, if I chose -1/3 and I divided by the term before it, which is a 1. I would still get -1/3. Or if I took the 1/9 term and I divided it by the term in front of it, which was -1/3. Now here I've got a fraction within a fraction. So I'm going to take the top and I'm going to multiply by the reciprocal of the bottom. and I would get negative 3/9, which reduces down to negative 1/3. However you want to do it is totally cool. Some people just can look at the list and they can figure out what they're multiplying by each time, but it is an option to use this idea of the common ratio. Okay, moving on. Here is your formula. This is a formula to find any term that you want in a geometric sequence. I'm going to write that out here. Allows you to find any term you want. Okay, a sub 1, that is your starting term. And then R is your common ratio that we just got done talking about. And then N is the term number. So like if I wanted to find the 10th term, I would plug in a 10 for N. All right, so here's our first example. Find the first 4 terms of a geometric sequence. The first term is a 3, and the common ratio is a negative 2. So that means that I'm going to multiply by negative 2 each time. So 3 times negative 2 would give me a negative 6. Negative 6 times negative 2 would give me a positive 12. 12 times negative 2 would give me a negative 24. So there's my first 4 terms. And then let's say we wanted to write an equation for this. So my starting term is a 3, and then parentheses. My common ratio is a negative 2, and then I'm going to raise that to the n minus 1. I think up here, the way this is written, it's fine. I would recommend maybe using this kind of version where you put the r in parentheses and then raise it to the n minus 1 like that. That might be just a little bit easier to follow. And then the only other thing I want to point out, and this is a common mistake I see, sometimes people, when they write the equation, they would take what I had here and they would say that that is the same thing as negative 6 to the n minus 1. And that is not correct. Because what that person would have done is they would have multiplied before raising to a power, and then that does not follow order of operations. So the exponents would always have to come first before multiplying. So don't write it like that. So here is your formula. And then if I wanted to find any term, like let's say I wanted to find the 10th term, all I would have to do is plug in a 10. So my a sub 10 is my 10th term. 3 times negative 2 to the 10 minus 1. And then I would just type this in my calculator. So I would type in 3 times negative 2 to the 9th power, and you should get negative 1,536. You should try typing that in your calculator to make sure that you did it correctly. This negative 2 does need to be in parentheses because a negative number, well, in this case it's to an odd power, will stay negative. But let's say this was an even power. If you don't put the negative in parentheses, it won't know to raise even the negative to the power. So just be careful. Type it in exactly as you have it written here. All right, next example. In the following geometric sequence, find a formula for a sub n and then find a sub 12. So it's very similar to what we just did in the last problem. Okay, if I want a formula, I need my starting term and I need my common ratio. Those are the 2 things I need. So here I can see that my starting term was a 5, and I just need to figure out what am I multiplying by each time. So looking at the list of numbers, looks like I'm multiplying by 3 each time. So I can write my formula, 5 times 3 to the n minus 1 power. And if I'm told to find the 12th term, I will just plug a 12 in for n. So 5 times 3 to the 12 minus 1. Plug that in your calculator, and you will get a pretty big number, 885,735. Because we're multiplying by something each time, these things are going to get big really quickly. The bigger r is, the faster this will grow. All right. And I think this will be our last example. This one is a little bit more involved. I want to find the 14th term, but this time I'm giving you the 4th term and the 10th term. So I'm not giving you the first term, and I'm not giving you the common ratio. So those are the things that we might need to figure out. Okay, so like if I was to make like my list, first term, second term, third term, fourth term. I know the fourth term is 125, and then fifth term, sixth, seventh, eighth, ninth, 10th. I know the 10th term is 125 over 64. And I want to find the 14th term, so 11, 12, 13, 14. So that's kind of what the problem is involving. I can see that the numbers are decreasing, so that would indicate that my r is something smaller than 1. So this is not the same, how do I want to say it? It's not the same process as when we found the common difference. So we're not going to use the idea of slope because it's not linear. So let me write this out. Geometric is not linear. So we can't use the idea of slope. Do you remember how that's what we used to find D? But D is the common difference. That's when it's arithmetic. This is a whole different kind of pattern. So we need a different way to figure out R. I'm going to write out the general formula. Okay, so maybe what we should do is take something we know. So for example, this right here. This signifies that when I plug in a 4, I get 125 out of it. So my answer is 125 when I plug in a 4 into the equation. Well, this doesn't really get me very far because I have two unknowns. I don't know what A1 is. I don't know what R is. So I kind of feel like I get stuck there. Well, maybe I will then take this other point and use that same kind of idea. When I plug a 10 in, I get out a 125 over 64. So that's my answer I get when I plug in a 10 for n. Simplifying that down just a little bit means I'm going to have a 9 as an exponent. And again, I feel like I get stuck because I don't know what a sub 1 is and I don't know what r is. So I've got two unknowns and I've got two equations. Well, I can solve. So let's use the idea of substitution to solve. Now, whenever we use substitution, you can pick either equation, either the blue or the pink equation, and you can get either letter all by itself. The a sub 1 can get all by itself, or the r could get all by itself. But go with the one that's easiest. So, in my opinion, I think getting the a sub 1 here all by itself would be the easiest because all I have to do is divide by r to the third, and now I have a sub 1 all by itself. Now I'm going to substitute this in for a sub 1, into my pink equation. So I will have 125 over 64 equals 125 over r to the third times r to the ninth. Okay, let's do a little bit of simplifying. On the right side, I have 9 r's on top and I have 3 r's on the bottom. So those are going to reduce. So if I cross out 3 from the top and 3 from the bottom, I'll be left with 6 r's on the top. Now, technically, this is all over 1. And because I've got a fraction equal to a fraction, I could cross multiply. So I could do 125 times 1 equals, and then I could cross multiply that, 64 times 125 times r to the sixth. And then I could divide by 125 on both sides. And I'll continue it up here because I'm running out of room. So if I divide out the 125 on both sides, I will get 1 equals 64 r to the sixth. I can divide by 64. And then to get r alone, I would have to take the sixth root of 1 over 64. And I can use my calculator to do that, and I'll get 1/2. So we now know that r is 1/2. If I want to find a sub 1, I can plug in a 1/2 for r. But what's my ultimate goal? My ultimate goal is to get the 14th term. I could start here at the 10th term. Now that I know what r is, I could multiply by 1/2 to get this next term here. So if I multiply by 1/2, let me get my calculator out. 125 over 64 times 1/2. We're going to get 125 over 128. I can multiply by 1/2 again. And we will get 125 over 256. And I can multiply by 1/2 again. Do you see how the top is always going to be 125 and the bottom is what's getting multiplied by 2? So the bottom now will be 512. And then I'm going to delete or erase this question mark so I can write in there. Multiply by 1/2 one more time, and we'll get 125 over 1024. And that is my 14th term. Let me write that somewhere down here maybe. A sub 14 equals 125 over 1024. Now, if the problem said to write an equation, then I would need to know what a sub 1 is. I could go backwards, and instead of multiplying by 1/2, I could go backwards and multiply by 2, because this is going to be bigger up here. Or I could just plug in what I know, that r is 1/2. So I could just in my calculator do 125 divided by 1/2 to the third. And that will give me my a sub 1. So typing that in my calculator, we get 1,000. So my first term is 1,000. Now if I want to write an equation, if I was told to write an equation, I have my first term, my starting term is 1,000, my common ratio is 1/2 to the n minus 1. That would be my equation for this, and I could find any term I want. So I could plug a 14 into here. I could plug a 14 in for n here and get my answer that way. So it just depends on what the question's asking for, whether it's asking for an equation or if it's asking for a specific term. And then what you're most comfortable with. You know, do you want to just keep multiplying by 1/2 until you get to that term? Or would it be easier if you wrote an equation and then plugged in a value for n to get a certain term? So like if this wanted the 100th term, I would not keep multiplying by 1/2 each time. That would take too long. So I would write the equation and then plug a 100 in for n. But this was only the 14th term, so it wasn't that bad to just keep multiplying by 1/2. So it's up to you, whatever you think is fastest. The only other thing I want to mention is the fact that geometric is not linear. And let me add in a page here. Okay, so just to kind of recap, arithmetic followed a linear model. Geometric, can you guess what that would be? I mean, think about like, if I give you an equation, you know, here's our general form. And let's pretend I gave you an equation like 3 times 2 to the n minus 1. Plug in a 1. Like maybe I'll make it an x. Let's make like an xy table. Okay, so if we made like a little xy table, if I plug a 1 in for x, that would be 2 to the 0, which is 1, times 3 is 3. Say I plug a 2 in. Now I'll have 2 to the first, which is 2 times 3, I'll get a 6. Let's put a 3 in. Now I'll have 2 squared, which is 4, times 3 is 12. Let's put a 4 in. I mean, you can see the pattern. We're multiplying by 2 each time, so I know this will be a 24. And then when we put a 5 in, multiply that by 2, I'll get a 48. So it's increasing pretty quickly. If you graph this, you'll notice that it is exponential. So I just wanted to point that out, the difference again between arithmetic and geometric. Arithmetic is when you are adding the same amount each time, and geometric is when you're multiplying by the same amount each time. Okay, that's it for today. You've got a Google form to complete, and that's it. Have a good one.